Now, let us look at this example. It's the same concept, the same geometry, the same length, the same supports, but now the load is at a point B at a distance A. Before we had a distributed load from capital A to capital B. Okay, so at this point they're asking us to do the same thing, find the diagram and the maximum values. So we know that the first thing is to consider the whole system, and a summation of forces equals to 0. We know that we have AX, AY at point A, and a point dy, no other x, nothing else, therefore AX equals 0. Summation of forces in y is equal to force P, which is the same magnitude. So we have AY plus dy minus P equals to 0. We know the value of P is the load. It's equal to positive 2P. So we have one equation, two unknowns. We need a third equation, which will be the moment. Summation of moment at A equals 0. Counterclockwise positive. This was very clear, positive. And at A, we know that we have P is clockwise, therefore that's a negative moment. P is also clockwise, but D is counterclockwise. So we have dy times L minus P times A minus P times L minus A, right? Because this distance is L minus A. All this is equal to 0. At this point, we only have to solve for the forces, which is dy and ay. So dy times distance is equal to the load times the distance a. This is in force, this is in distance, plus PL minus PA. So we know that dy is equal to P, and if dy is equal to P, then we know that ay is equal to 2P minus P, or ay equals to P. Okay, that is good. So we know that if we draw the shear forces, the diagram for the shear forces and the moment, L, let's say this is A, this is A, this is B, and this is C. All right, we have the points located. We know that we have a force AY equal to P, and we know that at D, we also have a force that is equal to P. So we have to connect this point and this point somehow. All right. We know also that the moment is 0 at these points, but we're going to find that in a minute. All right, so next what we can do is cut the section at some point X for B and C. So let's do that right there. Let's do for AB, we're going to have section with force AY, load P, and a cut V plus the positive moment. Okay, so we know that this distance is A and this distance is X. So summation of forces in x equals 0, summation of forces in y equals 0, and for this force in y, we know that we have ay minus p minus v equals 0. And ay was equal to p, therefore p minus p is 0, so v is equal to 0. And if we do the cut here, it will be ay, let's do the cut here. So here we have ay minus v, so this is ay equals to p. So, if we do the cut here, this is going to be a distance x prime. So summation of forces in y is equal to ay minus v prime equal to 0. So p is equal to v. Therefore, we can plot, or before the capital B as boy, we have that v, the shear force, is equal to p. Then we have that after B, the shear force is 0. Alright, so let's see if it's gonna change or not. This is symmetric, so I already know by intuition and experience that we're gonna have a case like this. But let's find mathematically what that means. So let's do a cut at point C. So we have this point right now. Actually, before we move on, we can do the moment. So at x prime, before p, the moment is 0 because the forces are 0. Well, hold on a second. I'm sorry. That is not true. It is p. V is p. So before capital B as beta, v is p. Therefore, the moment, summation of moments at a equals to 0, is a capital M, capital moment positive, minus, this is at a, so we have a v prime times x equals to 0. V prime is p, therefore m is equal to p times x. Okay, so it goes at, we have a slope of p. If you notice, this is ax plus b, but b is 0. So we have a slope of p. And that's intuitive because if you do integration of this is p. You do integration of p with respect to the x, you're going to have px at some point that we're trying to find. Therefore, this is going to be from A to B, a straight line. And then we found out that later we have a shear force of 0. So the moment will basically stay unaltered. We don't have any more moments, so it's going to be uniformly px. It's going to stay like that at a value of, this is p. This is a, this distance is a, therefore this is p times a. Right, because we have that at this point is px. If x is equal to a, then at b is pa. So p times a is this value, and here from b to c, we have a shear force of 0. So of course the integral of a constant of 0 is a constant. So that constant is going to be PA. So we don't have any shear forces to alter the moment, therefore the moment is going to be practically the same. You can see that since we don't have any more forces, then the moment over here, it will be basically the same. It will be basically the same moment caused by this point. There's nothing over here, so it's not going to go to 0 because here you have some previously defined moment. So it's just going to stay constant at PA. All right, so let's do the second point. The second point we have for AC, we have AY, we have our point C, so we have V, P at point B, and let's do a P at point C. Okay, so this is going to be A, and this is going to be L minus A. So summation of forces in Y equals 0. We have AY minus 2P equals, minus V equal to 0. So AY is P minus 2P equals to V. Therefore, we know that V at this point is minus P. Okay, so we go here and draw minus P. And we then can connect the force. Okay, so since this is going to be a constant force, a shear force, then we know that our moment is going to be straight line. And since this is negative P, this is going to be having a negative Px slope. Okay. And if you want to find that equation, then you do summation of moment at A equals 0. You have V times L minus A I apologize, you have this is L minus X. Then you have minus P L minus A. There you go. This is the value that we know. We really don't know what the V, the cut is any X, any variable, any value of the variable. Then we have another P times A. And then we have the moment, which is equal to 0. Therefore, we have that the moment is equal to, this is negative as well, positive L minus X, right? Because this is a clockwise, P clockwise, V is also clockwise, plus P L minus A plus PA. Let's try to solve for the moment. So we have V times L minus V times X plus P times L minus PA plus PA. Therefore, this and that cancel out. V is minus P, so this is equal to minus P times L minus Vx plus PL, and then you have your slope, and this is negative Px. Remember, V is P. This is the value of P. Let's do it like this better. All right, so we have our value of the moment. So this is how you do the example where you have, or the problem where you have loads at a point.